this video, we will explain about processor unit. So far we have discussed about different components, how to design the different components, ALU, shifter, then how to connect this ALU with the status register, etc. Then next we have to consider the combined unit. So this is a typical processor unit. We have ALU, this is our ALU, and we have three select lines. We have designated as F, then scene is also there. So based on these select lines and scene, we can have different arithmetic and logic operations on the inputs, two inputs here and here. So how to select these inputs or input information? So these two are actually multiplexers. They have three select lines. So by using these three select lines or select variables, we can select up to 2 to the power 3 or 8 inputs can be selected. So which are the 8 inputs here and here also? For the bus B select also we have 3 select lines, so we can have 8 input lines and we can select one from this 8 that will be available here. So here there is a register file. This register file has 7 registers. This is actually a set of registers organized as a single unit. So this bus is connected with the different registers R1 through R7. We have 7 registers, R1, R2, R3 up to R7. So this bus is connected to this bus A select and bus B select. So we have seven inputs from this register file, both to this one and one external input data other than from the register file. Okay. So we have 8 inputs to this side and 8 inputs to this section. So based on the select lines, 3 select line, we can select any one of these to this. If we are giving a 0 0 0 here, then this input data will be selected here and here. And if we are giving a 0 0 1, then register R1 will be selected. If we are giving a 0 0 1 0, register R2, like that here also. That's about these select multiplexers and corresponding selection variables. Then output of the ALU is connected with a shifter. This shifter will perform different shift operations on the output from the ALU, and the shift operations will be based on the H input. We have 3 inputs. Based on these 3 select lines, the different shift operations will be performed by our shifter. Then both this ALU and shifter will update our status register. This is our status register. Based on the operation or result of the ALU operation or shift operation, the content of the status register may change. Then the output data will be available here. That is also connected with the register file as a input to the register file. Then if you want to store the output result into any one of the register, then that can be done by using this destination select. This is actually a decoder. So we have 3 select lines here. So based on these select lines, 3 select lines, we can have 8 possibilities. If we are giving a 0 0 0 here, then no registers will be selected. The data will be available only through the output bus. But if we are giving a 0 0 1 here, then the result will be stored into R1. If we are giving a 0 1 0, then the result will be stored into R2. Similarly, if you are giving a 1 1 1, then the result will be stored into register R7. Okay, so this is for destination select. Then in this diagram we can have a number of selection variables or select lines. For identification purpose, we have numbered them as 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 16 selection variables are available here. And we have also given some labels for just identification purpose. That is A, B. These three are labeled as A, these three labeled as B, then this is labeled as D, then here C is a single line, then F, H, like that. Okay. So what is the use of these selection variables? Then control the micro operations executed within the processor during any given clock pulse. Also control the buses, the ALU, the shifter, and the destination register. In this diagram we have 16 selection variables. So we can combine. Next we have to discuss about the control word. So control word is actually a string of binary variables. When applied to the selection variables in the processor, specifies a given micro operation. So this is actually we can use this control word as inputs to our selection variables in our processor unit. So this A is corresponds to the A, the select line is labeled A in our diagram, and this B bits corresponds to the select line is labeled B in our diagram, like that. So this control word is actually a bit coded data. So each field will be connected with the corresponding select lines or selection variables in our processor unit. Okay. So when applied to the selection variables in the processor, specifies a given micro operation. So this is partitioned into 6 fields, with each field designated by a letter name. All fields except Cin have a code of 3 bits. The 3 bits of A selects a source register for the left input of the ALU. 3 bits of B select a source register for the right input of the ALU. The 3 bits of D selects a destination register. The F field together with the bit Cin selects a function for ALU. Then H field select the type of shift in the shifter unit. Okay. So these are actually the function of different selection variables. So if you are giving a 0 0 0 here, then what will happen? This is a field. Input data from the, this is actually AL select lines corresponds to here, this B corresponds to this one. So and D is the destination select. D is corresponds to the destination select. Okay. Then first we can consider the case of A select line. If it is 0 0, then input data will be selected. We already explained that. Okay, input data, if you are giving a 0 0 0 here, input data will be selected, and 0 0 1, then register 1 will be selected, 0 1 0, register 2 will be selected, like that. Similarly for B also. Okay. That is given in this table. If 0 0 0, input data 0 0 1, R1, 0 0 1 0 1 0, R2, like that. In the case of B, for B also the bit coding 0 0 0, input data 0 0 1, R1, 0 1 0, R2. Then this D is corresponds to our destination select. Okay, this is a decoder. So where we have to write our result back, into which register. If you are specifying a 0 0 0, then no register will be selected. That is, we are not storing the result back into any one of the register. Then if you are giving a 0 0 1, then R1 will be selected and the data will be returned, or result will be returned back to the result will be returned into R1 register. If you are giving a 0 1 0, then result will be returned into R2 register, like that. That is here mentioned, R1 R2 R3 R7. Then next we have to explain about the F field along with the Cin. That corresponds to the operation performed by the ALU. That is this one. These are the select lines connected with the ALU. These numbers are just for identification. Based on that we have formed our control word. Okay. So these three select lines, that is labeled as F, and Cin is a separate one. So by using these four select lines, we can have different arithmetic and logic operations. In the case of arithmetic operations, we based on the Cin value we can have different arithmetic operations. In the case of logic operations, there is no significance for Cin. We will use only these three inputs for select lines. So that is mentioned here. So if we are giving a 0 0 0, that indicates simply transfer. A means F is equal to A. That is the case. Just simply transfer. Along with that, we will set the carry flag also. This is actually the our previous design. We have already designed an ALU. That design itself is used here. That is, if 0 0 0, F is equal to 0 0 0 and carry in is equal to 0, then what will happen? A simple transfer will occur. Output will become A, and but this will also set the reset the carry flag. Carry flag will become 0. This operation will affect the carry flag. After performing this transfer operation, carry flag will become 0. Then for 0 0 1, A plus B will be the operation, and 0 1 0, A minus B minus 1. This is A plus B complement, that is operation, and 0 1 1, A minus 1 will be, or decrement operation will be performed. And if you are making Cn is equal to 1, then 0 0 0 indicates A plus 1 or increment operation, and 0 0 1 indicates addition with carry, and 0 1 0 is subtract operation, and 0 1 1 this is also a transfer operation. But here after performing this transfer operation, carry flag will become set or will become a 1. This in this case a transfer operation, but carry flag will become 0 or reset. Here carry flag will become 1. That is the difference between these two. Then logic operation, when 1 0 0, that is MSB bit is 1, then logic operation will be performed. So 1 0 0 indicates A or B, 1 0 1 indicates A XOR B, 1 1 0 indicates A and B, 1 1 1 indicates A complement. The Cin has no significance in the case of logic operations. Okay. Then okay. Then next we have to consider the shift this one, H field. H field is correspond to our shift select lines. We have already discussed a shifter in our previous class, but in that case there is only two select lines, H1 and H0, but here there are three select lines, so the number of operations supported will be more. So this was our previous shift unit. So this is a simple example for 4-bit shifter. So we have H0 H1 two select lines. Then based on these select lines, this will perform different operations, either simply load the values to output, or shift left or shift right, or simply load simply pass zeros. So in the case of right shift, we have to give some value through the IR serial input for the right shift, and for left shift we have to give some serial input that is specified, that will be given through IL input. So this IL is for giving serial input, and IR is also for giving serial input based on either we are performing left shift or right shift. Okay, this was our previous design, but in this design we have included some more one more select line, H select lines. We have 3 bits. So select the type of shift in the shifter unit. A third selection variable H2 is used to specify either S0 for the serial inputs IR, IL, or a circular shift with the carry bit C. So this will we can perform circular shift operation also in this case. Examples: circular shift, right shift with carry, that is R is equal to CR, that is equivalent to R is equal to shift right R, then Rn is equal to carry bit, then carry bit is equal to R1. Circular left shift with the carry, that can be represented by CLC. Then so based on the H input 0 0 0 no shift, 0 0 1 shift right, and IR is equal to 0 shift left with IL is equal to 0 0 1 1 zeros to the output bus. Okay, this 1 0 0 has no significance or not defined. 1 0 1 circulate right with C, 1 1 0 circulate left with C. 1 1 has no definition, not defined here. That's about the H select lines. Then next we have to explain or define one more terminology, microprogramming. So in our example, a control word of 16 bits is needed to specify a micro operation for the processor unit. The most efficient way to generate the control words with so many bits is to store them in a memory unit called a control memory. So that can store all the control words. The sequence of control words is then read from the control memory one word at a time to initiate the desired sequence of microoperations. This type of control organization is called microprogramming, and we will study this topic in detail in 6th chapter. Okay, so we will explain that when we are discussing the topics. Okay, thank you.